Hello students, in today's lecture we are going to learn about units and measurements. In previous lecture we already discussed NCERT section 1.1 and 1.2. Now this part of the today's lecture is units and measurement theory for JEE and NEET. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So in today's lecture we will cover first is measurement of length, then measurement of mass. After that we will learn measurement of time, then accuracy, precision of instruments and errors of measurements. So this is important. So our first topic is measurement of length. Here question arises, how we can measure the length of any given system. There are two methods for measurement of length as follows. First is direct method, second is indirect method. Clear? So our main aim to understanding the methods of measurement. First, our direct method. In this method, measurement of length involves the use of first is a meter scale and the range is 10 raised to the power minus 3 to 10 raised to the power 2 meter. Second is vernier calipers up to 10 raised to the power minus 4 meter. And third is screw gauge and spirometer up to 10 raised to the power minus 5 meter. So this one is just for knowledge. Second method is indirect method. So this method is used to measure large distances such as distance of planet or a star. So using the indirect method we can calculate the distance of planet or star from the earth. For example, parallax method and etc. For measuring mass of atoms and molecules, we use unified atomic mass unit denoted by U. If we want to measure the mass of any molecules and any atoms, we use unified atomic mass unit. It is the representation to measure the mass. So 1 atomic mass unit is equal to 1.66 into 10 raised to the power minus 27 kg. So this is the conversion. 1 atomic mass unit is equal to this one. Second is measurement of time. To measure any time interval, we use atomic standard of time, which is based on periodic vibrations produced in a cesium atom. This is the basis of the cesium clock called atomic clock. This clock has very high accuracy of part in 10 raised to the power 3. Now, accuracy, precision of instruments and errors of measurements. So this is the important, because in JEE and NEET question asked in various times. So our main aim is to understanding the concept of accuracy and precision. Now here question arises, what is accuracy? The accuracy of measurement is a measure of how close to the measured value is to the true value, while precision tells us to what resolution the quantity is measured. It means about accuracy tell us about the measured value. Suppose we have a two value. First value is theoretical value. Second value is experimentally measured value. So when we compare both theoretical value and experimental value, so from the comparison we can calculate the accuracy between them, while precision tells us what resolution the quantity is measured. Let's take an example. Suppose if in lab you obtain a weight measurement of 3.2 kg for a given substance, but the actual or known weight is 10 kg, then your measurement is not accurate. In this case, your measurement is not close to known value. Precision refers to the closeness of two or more measurements to each other. If you have any doubt, please ask regarding precision and accuracy. There is a two term, listen carefully. First is accuracy and second is precision. Accuracy tells us about the true value. Accuracy tells us about the true value, whereas precision tells us to what resolution the quantity is measured. So here we have an example. Listen carefully. In lab, you obtain weight measurement of 3.2 kg. Your obtaining data is 3.2 kg. Listen carefully. Your obtaining data is 3.2 kg for a given substance, but the actual or known data of the weight is 10 kg. So in that case, we can say that the data is accurate or not. The measurement data is 3.2 kg and the actual or known weight is 10 kg. Then measurement is not accurate. Yes or no? Yes, because measurement here the measuring value is 3.2 kg and actual value, known value is 10 kg. Both are different. So we can say in that case the measurement is not accurate. So basically accuracy gives us how any instrument, or we can say how close the measured value is true. Is there is a value true or not? 3.2 kg and 10 kg. Not true. Yes, because the accuracy tell us about the perfection, or we can say it is closeness to perfection. Accuracy tell us about the perfection of any data, and we can say closeness to perfection. So this is the main. Whereas if we talk about the precision, precision means it gives closeness of two or more measurements, or we can say repeatability of the measurement. So this is the main difference between accuracy and precision. This is clear? Sriram, Gaurangi. Difference in the true value and the measured value of quantity is called error of measurement. So what is error of measurement? Difference between true value and measured value. So here if we talk about the precision, if we talk about the accuracy, so here the measured value is 3.2 kg and accurate value is, or we can say known value is 10 kg. So there is an error. Yes or no? There is an error. So this is known as error of measurement. For example, if the true length of a piece of string is 10 centimeter and measurement is 10.5 centimeter, the error would be 0.5. Error would be 0.5. Any doubt? The errors in measurement can be broadly classified as systematic and random errors. So there is a two types of errors: systematic error and random errors. So first is systematic errors. Our main aim to learn or understanding of the types of error. So our first is systematic errors. Systematic errors are those errors that tend to be in one direction. Either positive or negative. Some sources of systematic errors are given as: first is instrumental errors. Instrumental errors arises due to impact design or calibration of measuring instrument. Whereas second is imperfection in experimental technique or procedure error. This error occurs due to external conditions such as change in temperature, change in humidity, wind velocity, pressure, etc. during experiment. So this type of error is imperfection in experimental technique or procedure, or we can say imperfection error. Third is personal errors. So personal errors, it arises due to an individual bias, lack of proper setting of the apparatus, or individuals carelessness in taking observations without observing proper precautions. It means systematic errors are three types: instrumental errors, imperfection errors, or personal errors. Clear? Any doubt? Our second type of error is random errors. Random errors are the errors that occur irregularly, irregularly and unpredictably during measurements. How we can understand the random errors? Let's take an example. When multiple measurements of the same object, multiple measurements of same object by the same person yield slightly different results due to factors like slightly different body positionings or reaction times. So this is the type of an example of random errors. What is your doubt? Random errors occurs due to multiple measurements of the same object by the same person yield slightly different results. Least count error. The least count error is the error associated with the resolution of the instrument. It occurs with both random and systematic errors. We know two types of errors: random errors and systematic errors. So least count errors occurs due to random and systematic errors. The smaller the least count, greater is the precision for a measuring instrument. Smaller the least count value, greater the precision. Some mathematical terms used for error calculations are given below. First is absolute error. Now here question arises, what is absolute error? The magnitude of the difference between the individual measurement and the true value of the quantity is called absolute error of the measurement. Suppose we have a two data. First is the individual measurement data. Second is the true value of the data. So the difference between individual measurement and true value gives the magnitude, and that magnitude is the absolute error. Suppose the values obtained in several measurements are A1, A2, A3 and AN. So there is a several values. The absolute error in individual measurement from the true value are this one. Absolute error is this one. Mode of A1 minus A mean. And mode of delta A2 is equal to mode of A2 minus A mean. So this shows the absolute error. And mode of delta AN is equal to mode of AN minus A mean, where A mean is equal to this one, A1 plus A2 plus A3 plus so AN divided by N. So this is the formula to calculate the mean value of the given data. Here we have a measurements values A1, A2, A3 and AN. How many values? There is a n values A1, A2, A3, A4, A5 and so on. So we consider n values, total n measurements here. There is a n measurements are present. Now if we want to calculate the mean value of the given measurements data, so first of all we add all the given data A1 plus A2 plus A3 plus AN and divided by n terms, divided by n. So this gives a mean, or we can say mean value. Clear? If you have any doubt, please ask. So let's take an example. Suppose we have a n data. N means the measured value is 2, 3, 4, 5, 6, 7, 8. There is a measured value. How many numbers? 1, 2, 3, 4, 5, 6, 7. There is a 7 values. Now we want to calculate the mean value. So to calculate the mean value, suppose a mean is equal to what? So add all these terms, means 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 and divided by 1, 2, 3, 4, 5, 6, 7 divided by 7. So this gives the mean value of the given, or we can say several measurements data. Now it is clear? Mean absolute error. The mean absolute error is the arithmetic mean of all the absolute errors, is taken as the final or mean absolute error of the value of physical quantity A and respectively represented by delta A mean. So if we want to calculate the mean absolute error, look at here. Here mode of delta A1 is the absolute error. Similarly delta A2 is absolute error. Similarly delta AN is the absolute error. Now using the formula of the mean value, so add all these absolute error and divide by number of absolute errors. So there is a n absolute errors. So add first absolute error, this one second absolute error and divide plus there is nth absolute error divided by total absolute error. So there is a total absolute error is n. So mean absolute error is represented by this form. if we do a single measurement, listen carefully, if we do a single measurement, the value we get may be in the range A mean plus minus delta A mean, where A is represented by this one. A mean means mean value plus minus change in, or we can say mean absolute, this one, mean absolute error. So this is the form of single measurement. Now there is a relation A mean minus mean absolute error is less than equal to A mean plus absolute mean absolute error. This representation implies that any measurement of physical quantity A is likely to be lie between in this range from here to here. This implies that any measurement of physical quantity A is likely to lie between this one, A mean plus delta A mean. Here a delta A mean means mean absolute error, and A mean minus delta A mean, or we can say mean absolute error. So this implies that any measurement value or of the physical quantity. Clear? Third is fractional or relative error. The relative error is the ratio of the mean absolute error, that is delta A mean, to the mean value of A mean of the quantity measured. So the representation of the fractional or relative error is this one. Relative error is equal to delta A mean divided by A mean. This is the formula to calculate the relative error. First is absolute mean error divided by mean value of the given data. Fourth error is percentage error. How we can determine the percentage error? When the relative error is expressed in percent, it is called percentage error, and that is del A. So here we delta A mean, this one, delta A mean divided by A mean into 100%. So it is what? Percentage error. This one. The percentage error is equal to delta A mean. Delta A mean means absolute mean error divided by mean value into 100%. So using this formula we can calculate the percentage error. Clear? Now question. Two clocks are being tested against a standard clock located in a national laboratory at 12 noon. By the standard clock, the readings of the two clocks are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and clock first and clock second and their readings. So here we want to calculate the correct answer. So if you are doing the experiment that require precision time interval measurements, which of the two clocks will give you refer? So what is the mean value? Please solve this question. Solution. So clock first and clock second, their readings. The range of variation over the 7 days of observations is 162 second for clock first and 31 second for clock second. The average reading of clock first is much closer to the standard time than the average reading of clock second. The important point is that a clock's zero error is not as a sufficient for precision work as its variation, because a zero error can always be easily corrected. Hence, clock second is to be preferred to clock first. Now, one question for you. Question is, you have a the clock values, this one. If we talk about the clock first, this one, you have to find out the mean value. How much the mean value? Please solve. The given data is this one. This one is given data. Now solve the mean value. The concept is, please add all the given data first, second, third, fourth, fifth, sixth, 7 and divide by 7. You will be get the mean value. We measure the period of oscillation of a simple pendulum in successive measurements. The readings turn out to be this one: 2.63 second, 2.56 second, 2.42 second, 2.71 second and 2.80 second. So the successive measurements readings are this one. You have to calculate the absolute errors, relative error or percentage error. Please calculate relative error, absolute error and percentage error. So the mean period of oscillation of pendulum is this one: t equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by 5. So overall sum is 13.12 and divided by 5 second. So the time period, or we can say mean period of oscillation, is 2.62 second. 2.62 second. We have to calculate the absolute errors, relative errors and percentage error. So this is the mean period only, mean period of oscillation. As per the periods of the measured to a resolution of 0.1 second, all times are to the second decimal. It is proper to put this mean period also to the second decimal. So the error in the measurements are 2.63 second minus 2.62 second is equal to 0.01 second. Similarly, 2.56 second minus 2.62 second is equal to minus 0.06 second. 2.42 second minus 2.62 second is equal to 0.20 second. And 2.71 second minus 2.62 second is equal to 0.09 second. And 2.80 second minus 2.62 second is equal to 0.81 second. So the important point here, errors have the same units as the quantity to be measured. Clear? If you have any doubt, please ask. Now your doubt time. If you have any doubt, please ask. If you have any doubt regarding errors of measurements, please ask. About the dimension, we will learn in next class. Yugnansh, absolute error is the magnitude of difference between observation and true value. Here, if you want to calculate the absolute error, you need to two value. First is observation value and second is true value, and find out the difference of the magnitude of the observation value and true value. Then you will be get the absolute error, or we can say magnitude of the absolute error. Clear, Ayush Mishra? Recorded lectures available on the website. The arithmetic mean of the absolute errors. For arithmetic mean, we take only the magnitudes. Is this one. Delta t mean is equal to 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 second and divided by 5. So sum of these values is 0.54 second and total values is 5. That's why we divided by 5. So the mean value is this one. Delta t mean is equal to 0.11 second. That means the period of oscillation of the simple pendulum is 2.62 plus minus 0.11, and it lies between 2.62 plus 0.11 second and 2.62 minus 0.11 second, or between we can say 2.73 second and 2.51 second. So here this is the period of oscillation of simple pendulum, and their range is this one, from here to here. If we want to calculate this, the answer is 2.3 second and 2.51 second. So this is the period of oscillation. Clear? Here we choose, look at here, 2.62 plus minus 0.11. So there is a two term we can write. First is 2.62 plus 0.11. Second one is 2.62 minus 0.11. So when we add this term, you will be get 2.73 second, and this will be 2.51 second. This one. This one is clear about the period of oscillation. Here question is accuracy proportional to precision? No, accuracy and precision are not directly proportional to each other. They are distinct concept in measurements. We already learned accuracy refers to how close a measured value is to the true or accepted value, whereas precision refers to how close repeated measurements are to each other, regardless of how close they are to be true value. Now clear? Any doubt? Hindi lectures are available on the website. Please visit sathi.puta.ai. Mehak Khan, Nishag Khataria. Hindi lectures are available on the website. Any doubt? No, I have one question for you. Question is, this is homework for you. You have given data, this one, 2.62 plus minus 0.11. What is the percentage error? What is the percentage error? Please find the percentage error. 2.62 plus minus 0.11. Sri Ram, 4.19%. So to calculate the percentage error, first of all we find out the mean absolute value of mean absolute value. Here we consider delta t, suppose, and divided by t and into 100%. So using this formula you will be get the mean uh, or we can say percentage error. Percentage error. Please solve. What is the value of delta t? What is the value of t? And multiply it with 100. You will be get percentage error. As the arithmetic mean of all the absolute errors is 0.11 seconds, there is already an error in the tenth of a second. Hence, there is no point in giving the period to a hundredth. A more correct way will be to write is this one: t is equal to 2.6 plus minus 0.1 second. The value of t is this one. The important point here is this: the last numeral 6 is unreliable, since it may be anything between 5 and 7. We indicate this by saying the measurement has two significant figures. In this case, the two significant figures are 2, which is reliable 6, which has an error associated with it. You will So about the significant figure we will learn in upcoming lecture. For this example, the relative error or percentage error is this one: 0.1 divided by 2.6 into 100%. So you will be get the percentage error is 4%. Now it is clear? Clear? So to calculate the percentage error. So first of all, you need to find the mean absolute error. So suppose we have a we find the percentage error. So the percentage error is equal to delta t divided by t into 100%. So here delta t is what? We already calculated, and t is, we here consider this one. So delta t divided by t into 100%, you will be get the percentage error. Clear, Alok? The about the uh, errors of measurements are not given in NCERT book. This is the part of JEE and NEET. And in upcoming lectures, we will learn significant figures. That is the part of NCERT. Clear? Any doubt? Kirat? So this concept is very important for JEE and NEET. In which section? Sriram, in which section? Absolute error is 0.11 second. Okay. What is your question? Okay, 0.1 and 0.11. Here we choose the value of absolute is 0.1. You also choose this one. Yes, in all NCERT have this topic. Clear? Okay, all right. No problem. Thank you for your attention.